week. We have next week. I think the week after that is Thanksgiving, so you've only got one day. And after Thanksgiving break, you're back for like a week, and then that's it. So you're actually pretty close to the end. That's good news and bad news. I mean, it's good news because you're like, wow, we're almost done with the class, awesome, Christmas break, all that fun stuff. But the bad news is a lot of people, with like a couple weeks to go, start like, all right, I can slack off now. Don't do that. Keep going to your classes, not just this one, but all of them, right? I mean, you've worked hard all semester. This is the point where you got to give that little extra effort and get over the top and get where you need to be. Not so much for this class. I think most people do fine with this class if they're paying attention. If they're doing things like they've been doing all along. But don't get overconfident with it. I've seen it happen once or twice. And I don't want that happening to y'all. So pay attention. I will be getting you your final essay study guide out probably early next week. You can expect that from me. You'll have it for a little while. The reason I'm going to get to you early is that I know almost none of you will be studying over Thanksgiving break. I want to give you a chance beforehand if you want to kind of start laying some groundwork, getting squared away. So, yeah, if anybody has any questions about that, make sure and get with me. You guys, as far as I know, I was looking at this morning, you're good to go up through the final. You've taken all the quizzes. We have one more quiz to take, but it's not really a real quiz. That'll be like the very last day of class. If you're not going to be here that last day of class, just get with me and we'll make other arrangements for you. But yeah, you're basically there. You're basically you're sitting there with the final test 3, whatever you want to call it, to go. So don't lose focus on what you got to do. All right, let's talk about armored fighting vehicles. This is usually a pretty popular lecture. I mean, I do know that there's a lot of people in the room who play various games that, they know a lot of technical details. I'm willing to be as technical with you guys as you want to be. I know a lot about this. I actually went to Armor Officer School in Fort Knox, so I know a fair amount about tank doctrine, and more than most of you probably want to know. I do like this lecture. I think I said in the email to you when I sent this out that this is a longer lecture by slides. So if you're like, oh my gosh, you're going through all those slides, yeah, it kind of depends. If we just breeze through these, we'll just give it one lecture. If we need to take this in the next lecture, I'll do that too. I'll make sure you're out of here on time. So we're talking about this technology of armored fighting vehicles. The definition for armored fighting vehicles, if you need to have that, is pretty simple. It's a vehicle with an internal combustion engine that has armor on it and a gun, and it's primarily designed for fighting. And know what I'm saying here. I'm talking in this whole lecture about armored fighting vehicles. That does not just mean tanks. Most people will say, okay, this is a tank lecture, and it kind of is. But in a broader sense, armored fighting vehicles, you'll see this distinction in just a minute. So when we talk about technology and the context of technology, we can go pretty far back if we wanted to talk about where the genesis of this idea is and where it's typically picked up and people start saying, yep, that's where the genesis of the idea comes from, is in the 1400s from the Renaissance man Leonardo da Vinci, who designed this thing. And if you look at it, what this is, you've got these 4 wooden wheels. You have a hand crank that a crew is going to sit there and turn through a series of interlocking gears. They power the wheels to turn and move along the ground. And then you put this metal-covered armored dome over the top of it. And the idea being that you're able to sort of roll around the battlefield at will. And of course, if you think about that, it's totally impractical, right? Something like this, made of wood, covered with metal, that's going to weigh several tons. You're going to have a very low surface area on your wheels to hold up this really heavy device. And if you're over any difficult terrain at all, little bumps in the ground, muddy patches, things like that, this thing gets bogged down. This is not practical. So it's the genesis of an idea, and it's the start of something. You can see people thinking of this, and they're trying to make use of an idea, but it's not really feasible in the 1400s. Now, in the 1500s, people reading books and things said, wow, how cool is that? What would it be if we could make something like that work? So they do the best that they can in the 1500s. The Russians develop technology, in English we'd call it a war wagon. A group of people in the German states called the Hussites developed the same technology, and it looks like this. It's basically just a large-sided wagon that makes use of firing slits. And you use your horse team to tow this wagon up to the fighting area, and then you move the horses out of the way, and you have this mobile fighting platform that is armored in the sense that you have very thick wood to protect the people inside. That's your armor. It's oak planking usually. It's anywhere between 1/4 to about 1.5 inches thick, depending on the various models and how they made them at the time. Now the reason that this is not really practical for fighting field battles is because of your means of propulsion. It's your horses, right? You can't really wield this into an ongoing battle because your horses will be killed and your vehicle will be stranded. And so the way that these things are used, they're entirely defensive, right? The only way you're going to use something like this is to laggard them up, to put them in a defensive circle and try to hold a hilltop or something. It's basically like a movable castle. You could move this castle from one place to another because it has wheels and horses to tow it. But in terms of any sort of offensive tactical action, this is not capable of it. But you can still see the genesis of the idea. So let's jump forward closer to our own time, much closer. We'll pick up in 1903 when a really famous man, a guy who wrote a lot of sci-fi novels, we're going to talk about him more near the end of the course probably, H.G. Wells. He wrote a book called War of the Worlds. You've probably heard of it. He wrote a lot of books, usually dystopian sci-fi. And he was writing about what the wars of the future would look like. He wrote a book in 1903 called The Land Ironclads, in which he said in the future you're going to have these wars fought by men in these tin boxes that are going to propel themselves across the landscape using a piece of technology which was called the pedrail wheel. And what this is, these little feet, these little heads, as it were, attached to this wheel as it rotates, they kind of step on the ground, and this thing is very ponderous and very slow, and it's technically a mess. I mean, something like this is so complex as a design. There's so many parts that can break and fail that the pedrail, as a means of propelling a very heavy armored machine across the ground, isn't really going to function. They do experiment with this, though. The militaries in the early 1900s, largely as a result of this novel, start saying, we should probably look into this, and maybe this is a technology that we could use to propel an armored vehicle. I'm going to tell you that the first modern armored fighting vehicles were not tanks at all, but were armored cars. Armored cars. The automobile existed as a technology in the late 1800s, and so it did not take a great technological leap for someone in the military to say, wouldn't it be good if we could put metal armor on a car and attach a machine gun to it, and you have an armored fighting vehicle. These are early examples of it. The earliest one that I've ever seen is 1902. It's a French design. This is a German-Austrian design of 1904. And when you look at this, you say, well, these things are useful to a sense, right? If you're fighting in a place like Europe, where you've got good paved roads, something like this is pretty useful in the early 20th century. You have a weapon, it's a Maxim gun, it's 700 rounds per minute or thereabouts. It can carry a good supply of ammunition. The driver and the gunner are pretty well protected. This one has a revolving turret. This earlier French design is pretty open. The driver is pretty exposed. There is sort of this upside down water trough looking thing with a Hotchkiss machine gun in it. The gunner is reasonably well protected, but you can see that there's some problems here. For one, people are shooting back at you, right? Presumably, if you're in a war and you're using something like this. How long is that going to last? Not long. Not long. Somebody with a bolt-action rifle, a Mauser-type design, firing it into the front end of the grill here on this armored car, you're done. Your armored fighting vehicle is going to end up in a ditch, not going anywhere by the side of the road. Other problems. If you look at the wheels on these things, they have a very poor ground-to-weight ratio. Their wheels are too thin, and so if they're going across cross-country terrain, grass and things like that, mud, something like this is going to bog down. These thin little wheels aren't going to spread the weight of the vehicle out sufficiently to allow for good traction. So it's got some limitations. And then, of course, you're talking about automobile technology being still fairly young and mechanical reliability of these engines not being superlative, right? So this isn't really going to meet the needs of this. When World War I breaks out, it's a war of position. It's a war that we've talked about before, very much attrition-based, very much static-based, in that these lines, the trench lines, don't move in one direction for basically 4 years. If you just look at pictures like this, you've got all the dirt churned up, very muddy trenches. You can see how an armored car is not going to navigate its way through this. It's just not going to work. And so you've got this need for change, though, technological need. Guys like this, infantry soldiers, over and over again, going over the top into no man's land. The armor protection that they have They have a metal helmet on their head, won't stop a rifle bullet. They're not wearing any body armor, completely vulnerable. They've got to have some type of protection. And after the massive casualties at battles like the Somme, where you have 60,000 English soldiers being killed in one day, July 1st, 1916, there's an outcry. Got to have technology to try to fix this. Technology is going to be the answers in some ways. Just not this technology. This is a British armored car from World War I. You look at it, you can kind of tell it's British. You look at all the rivets that are in it. I mean, this thing's clunky. Good engine. It's a Rolls-Royce engine, but really heavy vehicle. Not very well armored. Certainly not the solution to fighting like this. And so the solution is going to be adopted by this man, Winston Churchill. He's a British politician. He later becomes Prime Minister of Great Britain in the Second World War. But in the First World War, he is the First Lord of the Admiralty. And that may sound weird to you. The British Navy was tasked with solving this problem on the Western Front of World War I. The Navy fights at sea typically, not in the trenches in the mud. But the reason the Admiralty gets this job landed on top of them is that you have that earlier novel, right? You have this idea of land ironclads. It almost becomes like a naval problem. And so in February of 1915, the British government creates what becomes known as the Land Ships Committee, which is designed around the concept of building or creating a land ship, something that's massive and powerful and armored that will traverse the land like a battleship would at sea. And so the British start playing with this, and by September, they've built a prototype called Little Willie. By the following January, they built a larger one called Big Willie, and we'll show you some of the pictures here. Now, the difference that a few years made in technology was that the British Land Ship Committee was able to rely on this type of technology, 1915 and 1916. This solution, this technology became the way, right? You started to see this thing called a linked track, a continuous linked track that solved many of the problems of these earlier pedrail designs. Most of the technology being employed in the first tanks was actually drawn from agricultural tractors. Why? Because agricultural tractors are heavy, bulky pieces of machinery that have to be able to plow up and move through muddy farm fields. And so the thought process was, what we're doing is trying to create a very heavy, massive piece of metal machinery to move through the mud of the Western Front. Therefore, we should be able to apply some technology that already exists. We know that the pedrail design isn't really efficient. It's not going to work. But this continuously revolving linked track seems to provide the solution. And so as this committee was studying the problem, they said, our recommendation is to use the Caterpillar track, or this Caterpillar linked track. And for people who are like, well, what are you even talking about? You've seen this if you've ever seen a construction site. If you've ever seen something like a bulldozer or these heavy earth-moving pieces of machinery, you've seen this. It's just a continuously linked metal track. It's propelled or driven by a drive sprocket, and it runs along road wheels, which keeps the track lined up. And basically with this sort of thing, as you're driving a vehicle like this, if you wanted to turn to the right, for example, the driver, as he pulls the lever, it stops the right-hand track, the left one keeps turning, and it turns the vehicle, spins the vehicle on its axis on the ground. So you've got this linked track, this Caterpillar track. It becomes the way forward for armored vehicle development. Now this is a really interesting piece of technology, and a lot of people never think about it, although the linked track is the very heart of the tank itself. Without the linked track, without this piece of technology, tanks don't even work. They don't even function properly at all. Really, really interesting piece of technology. Most armies in the modern world that make use of armored vehicles, they have entire bureaus, entire groups that try to study this technology to figure out how to get the most out of their tracks. A track for an American main battle tank, modern day, costs something in the range of about $60,000. So these tracks are very expensive, they're hard to manufacture, requires a good industrial base to do it, and they are a real pain to have to maintain. When you maintain these things, if you were to change a track on a tank, Nothing like changing a tire, really, much more complicated. You have to take this giant pin that they've got, and you knock out a retaining pin holding the links of the track together. The track then slides off, and you have to drag the thing out, replace any of the links that have gone bad, and then reverse the process. It's very time-consuming, very hard to do. So some pictures of this technology. That's Little Willie. That's the first real tank. It's a test prototype. It's a test platform. And when you look at it, you can see what we've been talking about here the past few minutes. You can see this continuously linked track. They've taken that from agricultural tractor designs, and they've mounted an armored box on the top of it. And if you say, well, what a lousy looking weapon system, you're absolutely right. I mean, this thing is not a good weapon at all. It's capable of traversing some rough terrain, but the armor is straight up and down. It's vertical armor, which means that it has very poor characteristics for protecting the crew. In other words, if you have a projectile or a shot coming in at this armor, there's no deflection capability here. This is just straight up and down armor plate. And so if it gets through, you've got a real problem. Several other things you can see from these pictures. You can see the naval officer here. It's the Navy that's doing this in Britain, the Land Ships Committee. They're testing it. They're running through it. No turret. There's no revolving turret or anything like that. That won't come for several years more. This is a test platform. There's Big Willie. Big Willie is much closer to a fighting vehicle than Little Willie was. You can see the designs change somewhat. You've got this egg-shaped design. This is also sometimes called the British Mark I. It's got two revolving tracks on either side. It sort of runs the length of the entire vehicle. It's got a gun mounted in a sponson on either side. And the big concern with the Mark I, or Big Willie, is how big of a trench could it get across? Because the idea is that this piece of technology is going to be shifted onto the Western Front. And of course, they're going to have to cross trenches there, and that's what they're doing here. They're seeing what kind of clearance this thing has. Is it able to cross an 8-foot wide trench? Is it able to cross a 10-foot when they're testing it further and further to see where the breaking point for the technology is? So it's in 1915 that these first tanks get into action on the Western Front. They are not stunning as their technological performance. Some of the issues you can see here, tons and tons. They are riveted steel plate attached to a steel frame internally. They're very, very heavy. They don't have good engines, and they're operating in mud, which is inches and inches deep. And so you start to have these problems pretty quickly where they're breaking down, their mechanical reliability is bad. And so people will often ask about this technology, like what was the positive side of it? I mean, you're talking about a technology that's breaking down constantly, it's always getting stuck in the mud. Well, if you're these guys, if you're British infantrymen, and your job is to go over the top and walk or run across no man's land, yes, this is not great technology, but it's better than the alternative. It's better than going out there by yourself, fully exposed to machine gun fire. And so what they're hoping to use this for is rolling cover. It's just a rolling piece of cover that stays in front of them. They move along behind it and hopefully stay alive till the next day. Really bad handling characteristics. I may have mentioned this in the class before, but this particular tank model had a top speed. Its top speed on a paved road, not in the mud, but on a paved road, has a top speed of about 2 miles an hour, maybe approaching 3.
Well, on the left picture, what's the thing on the top of it?
Good question. Yeah, you got this weird looking structure on the top. That is to aid it in crossing trenches that are too big for it to get across. You basically swing this forward and you let it fall onto the ground, and you hope that your tracks are lined up so you're able to trundle across an open gap. It's a trench crossing device.
What about those wheels?
Back here, yeah, these wheels that you see also kind of like that. What they found is with this particular design, when it was going up an incline, it could handle anything up to about a 45-degree incline, but much more than that, and the thing started to have a tendency to rear up and flip over. And so this is designed to give you a few more degrees of clearance going up a hill before it becomes top heavy and rolls over, which if that happens, you're dead. There's no seat belts and you are falling onto a metal plate armor. And the rivets would really hurt. So, all right, so we're starting to get into these things called tanks. They are a type of armored fighting vehicle. And I want to give you a three-part definition for what makes up a tank. All tanks have a linked track, that continuous linked track. Ever since 1915, when the British said, yeah, this is what a tank will look like, it's what it's designed to do, they all employ a linked track. So until somebody develops some sort of anti-gravity device or something that lets these things float a few feet above the ground, all tanks will have this linked track. It's part of their characteristics. They have heavy armor. That's point number 2, heavy armor. Occasionally people will talk about, well, how thin can armor be and still have this thing be a tank? It's got to have armor heavy enough that could at least hope to stop small arms fire. Okay, so much thicker, much heavier than, you know, the sheet metal on a truck body or something. And finally, it's got substantial weapons, the third point. It has to have substantial weapons, something like this main gun. This is a British Chieftain, a British Chieftain tank in the 1980s. Main guns today are generally about 120, 125 millimeters in diameter. But substantial firepower. Mobility, armor, and firepower. These are kind of the three characteristics of any good tank. So when people are talking before class for a few minutes about like tank design and what makes a good tank, I mean, whatever country we're talking about, mobility, armor, and firepower. Getting those three features in the right ratio, designing the technology in such a way that those three things are present and effective, that makes a good tank. Occasionally people really like talking about World War I tanks. I've read memoirs of these things. I've never actually been in one, but they were extremely loud. You're standing inside a metal box. There's a crew of 6, sometimes 7. You've got 2 drivers up front. The commander stands behind them. You have your gun crews, which operate the guns on either side, and you have your engineer, or engineers sometimes, who are back here manning this central engine. It's heavy. It's not super effective as a weapon. It's got blind spots. I mean, if you are rolling across no man's land and your driver looks out his hatches and sees an enemy threat directly to the front, you're screwed. Your guns can't traverse to meet that threat. So this is bridge technology, is one way to look at this.
Can I get the neighbor's house?
Yeah, sure. Absolutely. So the things that the early tanks do well is crushing barbed wire. This is their big claim to fame. Yeah, they're slow. Yes, they're unreliable. Yes, they're not really awesome, decisive battle winners, but they are really good at using their weight to crush down barbed wire so that the infantry can get through. And that's what they do. That's what they do well in World War I. The first few battles involving tanks, in September of 1916, there were 2 British tanks that were involved in a very local attack at the Battle of the Somme. This attack involved these 2 British vehicles trundling forward. They reached German lines. The German troops panicked because they couldn't get through the armor with rifle and machine gun bullets and ran away. But these 2 British tanks promptly broke down in the mud and had to be abandoned by their crews. So kind of anticlimactic first use of tanks. The British tried again at Cambrai in 1917. They learned a little bit from this, and they had some follow-on forces. The first tanks approached the German trenches, similar result. German troops not really able to stand too well in the face of this. The subsequent waves of British tanks broke through the German lines at Cambrai. They actually tore a hole in the German defenses, but there was no force available to exploit that breakthrough. So they tore a hole in German lines. There was a gap there for a few hours as the Germans reinforced and backfilled the line. And so in both cases, the British early use of these tanks were not particularly stunning as some sort of a war-winning weapon. Most of them in action in World War I ended up broken down in the mud. That was honestly the way most of them ended up. So the British, though, as a result of their experiences in these battles, they start saying, well, how is it we can make this work better? And they develop a doctrine called the Armored Breakthrough Doctrine, which said that the role of tanks, the way that we're going to use this stuff in a war, is to punch a hole, like an armored fist, drive a hole through the enemy lines, and then we will get into the rear areas of the enemy army and we'll defeat that enemy army. This idea of using tanks as sort of the armored spearhead, armored breakthrough doctrine. So, these early tanks, what's going wrong with them? All sorts of mechanical problems. They break down all the time. They're slow. They're hard to maneuver. If you think about trying to drive something like this through a rubble-strewn street, you've got a real problem. This thing's not really technology that you would think of as being war-winning. So it's really interesting. I mean, people make fun of the British tanks in World War I all the time. They're easy targets because there's so much wrong with them. But it's kind of interesting that the Germans copy the same thing. The Germans are looking at the British tank designs and saying, we need something like this. And so late in the war, it's not until the final year of the war that the Germans build their own tank. It's called the A7V, and it's this monstrosity. They only build 20 of them in the course of the war. They have several guns. The main gun is this one in the front, 57 millimeters, single gun. And they have 6 machine guns, 3 per side, a crew of almost 20 men per tank. This thing really is a land ship. It is far larger and far heavier than the British tanks. And there is actually one battle at the very end of the war where British tanks run into these A7Vs. It's the first tank versus tank action ever. It involves this thing up against the British. Battle called Villers-Bretonneux, 1918. Kind of anticlimactic as well. The battle involves some of these vehicles bumping into each other. It's a foggy morning. They fire several rounds at each other. 2 of the British tanks are knocked out, one of them because it sheds a track. The track comes off as they're trying to maneuver. The German vehicles end up breaking down and their crews have to retreat. So again, you think about this technology, it becomes almost synonymous with modern warfare. And you say, why is it pursued? Well, it still does do several things well. It supports the infantry moving forward. So we've talked about the British and their Mark I. We've talked about the Germans and their A7V. Let's talk about the French a little bit because this is an important design. Some of you know quite a bit about this tank already. I know you do from conversations I've had. So I'm not going to get too much into the technical specs here. The French look at the German and the British experience with tanks. And they say, we want tanks in the French army, but we get it. We get that having these super big, super heavy tanks only results in these things breaking down in the mud. We don't want that. We're going to go a different way. And so the primary tank that the French design is small, it's light, and it's fast. It's this thing. It's the FD-17. It's made by a company called Renault. It has a crew of 2 people, just 2. You have a driver who sits down here in the hull, and you have the commander gunner who is seated on this sling seat in this revolving turret. There's not even a cannon on this thing. It's just a machine gun that's mounted in the turret. Here's the internal workings of something like this. You've got the engine in the back, the driver up front, and a 360-degree rotating turret with the commander and gunner in there. It's a completely different style of trying to use tanks. The British and Germans are building big, heavy things, and they're trying to use that armored breakthrough doctrine. The French say that's not working. We're going small, light, maneuverable, and we're going to try to use our tanks to support the infantry, not to break through in this massive struggle of armored titans. So when the United States comes into the war, we come in 1917, and we don't have any tanks. The American Army has none. The British have been playing with this, the Germans have been playing with it, the French are building these FD-17s. Yeah?
Real quick,
Yep.
when was the first tank versus tank?
Villers-Bretonneux. There you go. Don't worry about the spelling so much. It's just the first tank versus tank battle. Kind of anticlimactic, really, in all honesty. All right, so the U.S. comes into the war, and we're like, well, whose tank do we adopt? And you say, well, the British one breaks down and gets stuck in the mud. The German one is super heavy and has similar type problems. It appears that in World War I, this is the answer. And so America says, that's ours. We're gonna buy a bunch from the French, we're gonna use them. It's got all kinds of cool features. It's the first modern tank. It's got this turret, it rotates 360 degrees. It's got an engine that sits in the back of the tank, so if you're advancing towards the enemy, your engine's not as vulnerable. It's got this crew compartment forward, driver, and then the commander. Do you have a question? Or you? I thought you saw me move your hand, sorry. Okay, so here we go, late war. US infantry, they're all marching forward behind this FT-17 tank. This is America's first tank. Now, why am I even talking about this being America's first tank? Well, because it's gonna be something that comes up in a minute. A lot of students will have questions and this will answer it. So when we get after World War I, America's experiences with tanks and armored warfare is this tank, the FT-17, and it involves the trenches of World War I. And you have a guy like this, I don't know if you know who that is yet, but you're about to, but George Patton. He's the most famous American tank general of the Second World War. He cuts his teeth on this stuff. This is where he learns armored doctrine, armored warfare. And it's this particular piece of technology that says, yeah, this is the way we're going to fight. It's the way we're going to deal with armored warfare problems. So it's one of the truisms of history that when people fight wars, as soon as the war's over, sometimes while it's ongoing, they say, what lesson do we learn? We just fought a war. What do we learn? What do we need to fix? What technology do we need to fight in the next war? They're trying to apply previous lessons. And so the interwar period is super interesting from a technology standpoint. It's super interesting to me how you get this nexus of technology and thought. What do we think we need for the next war, and how are we going to try to use this technology in the future? Plus, you have technology and where that crosses over, where it actually works and sometimes it doesn't. So the interwar period, lots of changes, because people are looking at the situation, they're saying, if only we'd had better technology, tanks would have worked better. Yeah, right, obviously. Developments in design. This is an American named J. Walter Christie. He was a car racer. That's what he did for a living for a while. He's a professional automobile racer. And he's really, really interested in how to make motorized vehicles able to perform better off-road. He's somebody, he would have been a rally car driver if he lived in modern times. He's interested in driving fast off-road. So he develops a suspension system, which is called after him the Christie suspension. And so this Christie suspension is initially just applied to automobiles, high octane racing cars. But fairly quickly, Christie starts saying, but wait, my technology, this Christie suspension thing, would work equally well with an armored vehicle. It would allow an armored vehicle to do things like at high speed traverse obstacles, just run right over top of them. It allows for greater stability while you're driving across country at high speeds. And so he builds this Christie suspension in the 1920s. And using his own money, he buys technology like this, and he starts installing that suspension system and driving around really fast. And why is he doing this? Well, part of it is that he's just fascinated with this kind of technology. He's just into it. But the other part is that he's hoping to attract some government contracts. He's hoping to get the attention of various militaries who will then say, we will purchase your Christie suspension system and use it on our armored vehicles. Now, it's really kind of tragic what happens in some ways, because he goes to the American military. The American military in the 1920s has had its budget slashed. World War I's over. So the American military says, well, it's a cool idea, but we don't have the money to pay you royalties for it, thanks. The British turn him down. The Germans turn him down. The French turn him down. The one country that actually takes him up on this and actually starts installing the Christie suspension in its vehicles is the Soviet Union. So it's in the 1920s and early 1930s that Russian tanks start applying this system. They start putting in the Christie suspension system. And it means that the Russian tank designs of the late 20s and early 30s are better at moving across country at speed than in any other country. This Christie suspension gives them that technical edge. So money and budgets are the big reason why Christie gets turned down. Bureaucratic inertia is the second. This is the idea that, well, we don't do things that way. People don't like to think outside the box. And so Christie gets turned down for that reason. The third one is something I really want to talk about for a minute. It's something that military historians call victory disease. Victory disease. This is a mindset or a mentality that emerges or develops whenever a country or a government has achieved great success in a war. If you've just won a big war, the tendency is to be like, yeah, we're awesome. We got this. We don't need to make any changes at all. That may be true. But the loser in war typically looks at the situation and says, we need to innovate. We need to adapt new technologies. So in the interwar period, governments like the British and the Americans, victors in World War I, they kind of rest on their laurels a little bit. They kind of take a break and say, we don't really need to innovate. We don't need new technology, new ideas. The problem is that other people in those interwar years are innovating very much. Now, in the interwar years, the American armor doctrine and technology looked a lot like this, tanks like this. You have the M3 Stuart. It's a very small, light tank. When you look at that M3 Stuart, it should look familiar to you a little bit. It's basically like an upgunned, a little bit up-speeded version of the FD-17. Same idea, super tiny tank, very light, very quick. That's what it is. It's a modernized FD-17. Now the Americans are sort of in this odd position in terms of what they think they're going to have to do with tanks in the future. Because they're like, okay, in the last war, we used light tanks, those French FD-17s, that were infantry support tanks, and that worked. That was kind of the way we did it. But it kind of nags at them in the back of their mind, the British, the Germans were doing this heavy tank thing, so maybe we need heavy tanks as well. The Americans are sort of odd in the interwar years because they're developing light tanks, but then they're also doing heavy tanks. And the heavy tank is this thing called the M3 Grant. It's really a crappy tank. Not good at all. 37 millimeter gun in the turret, not really heavy enough to knock out another tank. It just gives you greater height, which is actually a disadvantage in tank fighting. You want to be as low to the ground as possible to give yourself a lower silhouette and a smaller target. This is a really big target. And then the main gun is this 75 millimeter thing that cannot be turned left or right really. It can be elevated or depressed, but you have to turn the entire tank to turn the main gun itself. It's not a good design. If you look at the armor of this thing, not that great either. You can see these rivets in the hull, and riveted armor is really bad news for the Second World War, because if you have a shell hit that, what happens is even if the shell does not penetrate the armor, doesn't get through into your crew compartment, the little rivet heads will pop off inside and bounce around, just like having a hand grenade go off in your tank or something. Bad idea. The British in the interwar years are trying to build on their own experiences. Now, all they really know in Britain is heavy tanks. They haven't played around much with the idea of light, highly maneuverable tanks. That wasn't their style in World War I. So the interwar British tanks, like the Matilda and the Churchill, are very, very heavy, they're slow, and they have a lot of armor. Now, having a lot of armor is good. I mean, that keeps you safe. It protects you from people shooting at you. But being slow is a real problem, and that's going to be something that comes back to harm the British pretty substantially during the war, is the fact that they didn't really focus on speed, and especially because they never adopted that Christie suspension, they lacked cross-country mobility. So this is, in my opinion, there are people who've written all sorts of things who disagree with me, finest interwar tank developed between the world wars is a Russian design. It's this thing. It's called the T-34. It makes use of the Christie suspension, so it's got super good cross-country mobility. It has decent armor, and it's got a really good 76 millimeter gun. High speed, decent armor, good gun. Now, people will criticize this tank occasionally. They'll say, yeah, but it was really uncomfortable for the crew. It's a Russian tank. The Russians don't care so much about their crewmen being comfortable in the tank. It protects them, it's got a good gun, and it's got good cross-country mobility. It's arguably the best tank of the interwar period, and maybe of the Second World War. So, in terms of technology, technology can be compared with other technology pretty easily. But as I said, I think one of the best ways to understand this is to look at technology and how it interacts with doctrine. Doctrine being this concept of how you think you're going to use the technology. How is it we think we're going to fight this next war? And so we've got, in the interwar period, several people's names who some of you may have heard of. J.F.C. Fuller was a Brit, and he came up with this doctrine called the spearhead attack. Now, what was this? This was basically just a refinement of that World War I British doctrine. You use tanks as an armored fist to smash a hole in enemy lines. J.F.C. Fuller said, I'm going to call that spearhead attack because it sounds cool, cutting edge. Sold books about this. B.H. Liddell Hart said, well, J.F.C. Fuller had a good idea. You use this armored force to tear a hole in enemy lines. But he said you have to then exploit that. How do you exploit it? Well, you use combined arms. Everybody says, what does that mean? It means tanks, infantry, artillery, air power, combining all these different elements of warfighting into a hopefully seamless whole. Sounds good, combined arms. The Russian, Marshal Tukhachevsky in the 1930s said, and once you tear a hole in the enemy lines and exploit it with combined arms, you then seek to defeat the enemy through this doctrine of deep battle, which means you rip a hole in the lines and you go straight through it, way into the enemy rear areas. You rip up their supply convoys, their oil depots, and everything else. This is sort of the twisting the knife, so to speak, once you've stabbed it into your opponent. So all of these doctrines, they're all good on their own, but their real importance has to do with this German general named Heinz Guderian. And in 1937, Heinz Guderian writes a book called Achtung Panzer, which means attention, tanks. And in this book, Achtung Panzer, Guderian lays out the playbook for a new German doctrine called Blitzkrieg, or lightning war. And what he basically has done, and many people say, oh, he's such an original thinker. Yeah, he's a bright guy. But he's taken Fuller, Hart, and Tukhachevsky, and he's combined it. And he's saying, okay, here's what we're going to do. Yes, spearhead attack by tanks. Yes, exploiting that by combined arms. Yes, fighting a deep battle very quickly that unseats the enemy from his position of balance and quickly defeats him. Lightning war, Blitzkrieg. You knock the enemy out before they even realize they're at war in some cases. So this system that the Germans come up with relies on the technology of the tank. This German Panzer, German tank, is the centerpiece of this new doctrine, but it's backed up by German air power, German mechanized infantry. The tank smashes the hole in enemy lines. You keep enemy reinforcements from arriving using air power, and you exploit that with mechanized infantry, which keeps up with the tanks because they're in armored half-tracks. So now we're up to the Second World War, where all these theories and technologies of the interwar period are going to actually be put to the test, right? Historians talk about this, and I think it's a good way to understand this. All the thoughts and ideas of how we're going to fight a war and the technologies we build to do that with in peace, they're all put to a very severe test. The hard schoolhouse of war. You figure out real quick, does this work, does it not? Is it actually something that we can actually make work? So we'll talk first about the Germans, because the Germans have developed this Blitzkrieg doctrine, and it's going to actually be incredibly effective. Now, the German early war tanks are kind of interesting, early Second World War, because they range from something like this, the Panzer Mark I, it is smaller than a pickup truck, to something like this, a Mark IV, which is much bigger than a truck, weighs a lot more, has a revolving turret with a 75 millimeter, in this case, high velocity gun. Highly effective tank, not so effective, right? They've got kind of this mishmash of vehicles because they're not quite sure what the war is going to be like. Is it going to be light tanks, as was the case in World War I, or is it becoming more of the heavy tank model? Well, they find out in the spring of 1940 that the German model of Blitzkrieg is super effective. We know that now. Everybody's like, well, duh. They didn't know that in 1940. They learned this pretty quickly, though. So what they find in these tank battles of 1940 is that the German panzers, these German tanks, get the better of their French and British counterparts. But it's not because of technology. It's not. These German designs are not technologically so much better than the French and British. In many cases, the French and British design, tank versus tank, are better vehicles than the German ones. The Germans have a tendency to overcomplicate things. The Germans have a tendency to try to make the technology so seamless and perfect that it's great in a showroom, but when you put it in the field, it has technical problems. And so these German tanks, while they're decent, they're not like superlatively better than the French and British. So why is it in the early war then that the German panzers just wipe the floor with the French and British? It's not technology, it's doctrine. part of this blitzkrieg doctrine said that German tank units would mass their tanks, and when they attacked, they were throwing 200 or 300 tanks at an objective. The French and British divided their tanks out piecemeal. And so they'd have an infantry company that might have one tank in support of that infantry company. The Germans attacked in a whole mass at the critical point, which the Germans call Schwerpunkt. They attacked at a critical location. They achieved local superiority. And so these French and British tanks, this is a French tank, that's a Char B, has been knocked out in 1940. It's not that it's worse than the German designs, but it's been outclassed because 5 or 6 German tanks are converging on it. The French tank can't hold out. So it's doctrine that is the way that the Germans win the early stages of World War II. And you saw the movie Dunkirk, it came out fairly recently, that involved the German Panzer Arm, the German tank forces, sweeping through the Ardennes forest along trails that the French army believed were impassable to tanks. They didn't bother to guard them. The Germans come right through it. They spring out in the French flanks along the rear areas of the French army, and they bottle the French and British up. Dunkirk, the British barely managed to escape. The Germans almost win World War II in the early stages. But then the Germans make a mistake, because the Blitzkrieg doctrine was tailor-made for Western Europe. It was tailor-made for fighting in France and Germany and places with good roads and decent weather. The problem is that in 1941, the Germans say, let's apply Blitzkrieg theory in our invasion of Russia. Russia is a huge country. The roads are terrible or non-existent, and the weather's really bad. So this German tank arm comes into Russia and has some problems. You can see that's a Panzer Mark IV. It's being towed by this SDKF Z250. It's just a half track. That thing's broken down in the snow. German vehicles were not built to operate in sub-zero temperatures like this. They had a hard time because they were fueled with regular gasoline. They had a hard time operating in the snows of Russia. Their fuel lines would freeze. They had all kinds of technical difficulties. The Russians, twice a year, have a weather event called the Rasputitsa, which is where the snow falls and then it melts again in the spring. And this is what it turns into, quagmire, right? The Russians are used to operating in this, the Germans are not. So there's dozens of images like this from the Russian campaign. These German tanks, which just can't operate in these conditions. If you look at these Germans, these are Panzer Mark IIIs, if you look at the narrowness of the track, that's going to sink in snow. You try to drive this tank across a snow field, that's going to sink up to its axles in snow. It doesn't have wide tracks capable of holding the tank up on top of a snowy surface. What these guys are doing, really interesting and dangerous too, the fuel lines are frozen in these tanks. They can't start them. So anytime a German tank column on the Eastern Front prepared to move, they required about 2 hours notice. In those 2 hours, the crews would get out and they'd gather wood, they'd pile it up under the tank and set it on fire. And they would literally melt the ice away from the engine of their tank that way. That's dangerous though, right? You're gonna lose tanks doing things like that. If you have a tank that you have to light a fire under it literally to be able to run it in this condition, it's not the right technology for the job. Russian tanks don't have that problem. Russian tanks are diesel powered primarily, and they've got this wide track which enables them to drive across snowy fields with relative ease. Even the angles on the back fenders of these T-34 tanks, they're angled in such a way as to shoot the snow off to the side. So as these things roll through the snow, they don't get all clogged up. Their tracks don't get clogged up that way. It's just a better design for the environment. It works better. Yeah.
You said they were diesel powered. How did they deal with gelling? Because then diesel would start gelling about 20 degrees, whereas gasoline doesn't freeze and so much.
Yeah, the Russians actually have the engine warmers. They'll press it. It's like I guess an electric motor, and they'll warm it. So they're not having to build fires under their tanks. Yeah, it's a good question. Huge arguments about this because there's some people like, oh, these Russian tanks are just garbage. They're just mass-produced pieces of garbage. Actually, the technology, they're better, in my opinion, than the German tanks. So the Germans realize that they're being outclassed armor-wise. They pick up on this. Yeah, you got it. We understand. We're going to have to develop new designs. So in 1943, German arms designers go to work, and they are working overtime to try to fix these problems. And they come out with these two designs. Hitler calls them some of his Wunderwaffe, means wonder weapons. The Panther tank and the Tiger tank. And Hitler loves these things. These are going to win the war for him. This is arguably the other best tank of World War II. It's not the Russian T-34, it's this one. Has a high velocity 75 millimeter gun, has thick sloped armor, has a decent engine, works pretty well. This one is much larger. The Tiger's bigger than the Panther, has an 88 millimeter gun, very heavy armor, and a super crappy engine. German tank crews in the Tiger were constantly complaining because every time they started or shut the tank off, fuel, raw fuel, would leak into the crew compartment. It wasn't very well designed as an engine, especially the Porsche variants. They had some real problems with that. So Hitler's developed these new designs. They're bigger, they're more powerful, bigger armor, bigger guns. That's the answer. And so he's hoping to be able to throw the knockout punch with these. But part of the problem is that German industry was not capable of producing these things in sufficient numbers. So all he's really done, all the Germans have done in 1943 is said, bigger tanks, more armor, heavier guns. Everybody else can do that too. The Russians can do it. The Russians can build bigger tanks with bigger guns and heavier armor and lots more of them. T-34, it's a venerable design, it works. The Russians say, okay, we've got to get through thicker armor. We're facing bigger tanks from the Germans. How do you do that? You stick a bigger gun on a T-34. Take off the 76 millimeter, retool it a little bit, and put on an 85 millimeter gun. It's the same tank, primarily, just got a heavier gun on it, an 85 millimeter gun. Things like this, the Joseph Stalin II, that thing is a beast. The Russians built these two designs to be able to knock out Panthers and Tigers. That was their main interest in what they were doing. So they're still playing with this concept. What's the successful tank design? The Eastern Front became largely a contest of size. The Germans started building this thing. It's called the Ferdinand. It's a giant tank destroyer. It weighs nearly 70 tons. That's without its ammunition load. An 88 millimeter gun. Oddly enough, it had no machine gun, which meant that Russian infantry figured out pretty quickly, you don't want to step in front of it, that gun's really deadly. But if you come at it from the sides or behind it, even on foot, as a foot soldier,